Welcome to the Archaeology Studio. Today's episode is concerned with climate and sea level in archaeological studies. By the end of this episode, you will be prepared to discuss how climate and sea level have changed through time. You can consider how these changing conditions have affected the physical shape of the world, as well as how people could live through those transformations. Through time, the global sea level has changed due to the fluctuating amount of water filling the world's oceans. The major controlling factor has been the worldwide overall temperature. During colder periods, such as during an ice age, more water is trapped inside ice sheets, and therefore the oceans contain less water during those periods. During warmer periods, the ice sheets melt, and therefore more water can enter into the oceans. We all should be aware of the world's overall periods of climate and sea level, the major periods related to the ice ages, and the counterparts between the ice ages. Numerous other periods involved less magnitude of change in climate and in sea level. Coastal environments tend to be the most vulnerable to the effects of changing climate, and especially sea level. The most obvious results are seen in the reshaping of landforms and habitats, with practical implications about where people could have lived, how they could have used their environments, and how we can interpret their surviving archaeological signatures today. While coastal areas can reveal the most dramatic effects of changing climate and sea level, all terrain settings of the world have been affected. The largest influence on sea level comes from the ice sheets on land. In these cases, the meltwater directly alters the level of the ocean. In other cases, ice already is floating on the surface of the ocean, and this melting can create little or no visible change in the level of the ocean. In all cases, the displacement of large amounts of water can cause deformation of the ocean mass as a whole, and especially near the surface. The events of melting and freezing can create large volumes of water that move in variable ways across the world's oceans. The outcomes depend on the amount of water, the speed and magnitude of the original event, and the shape of the ocean basin. Overall, we can look at the world's long-term records of climate and sea level, and we can identify a number of major periods through time. During the last major ice age, enormous amounts of water were trapped inside ice sheets, and accordingly, global sea level was more than 100 meters lower than today. With those conditions, the world looked remarkably different from what we can experience currently. Generally speaking, we can look at the major continental shelf formations, and we can imagine that they had been above sea level during the last major ice age. During those times of more than 100 meters of lower sea level than today, the land shelf and land bridge formations were extensive. These conditions were part of the human experience for many thousands of years. Importantly, during the periods of some of the major episodes of human migrations around the globe. In a long-term view, our historically recorded world has been essentially a drowned world. We no longer can see the coastal landforms and ecologies that had characterized the world for thousands of years. Regarding the majority of human existence, our coastal archaeological sites mostly have been submerged deep under the ocean and thus rendered invisible to us today. At a minimum, we need to be aware of the missing millennia of the coastal archaeological records. In most places of the world, we have little or no way of accessing information about ancient seashore sites older than about 8,000 years ago. With this imbalance of basic information, we need to be cautious about how we interpret the roles of coastal environments during different time periods. The site-specific details can be more complicated due to several factors. Tectonic issues can create uplift or subsidence with variable outcomes. The degree of vertical displacement usually is on the order of a few millimeters or less per year, or even per decade or century. The results are seen in uplifted limestone formations, as well as in classic tidal notch exposures. One of the world's most impressive cases of uplift has been documented in eastern Taiwan, calculated at nearly 1 centimeter per year. This rapid uplift can be traced according to direct dating of corals now raised far above sea level. Several archaeological sites now are situated at 40 meters elevation on low hilltops, but originally they had been situated at the ancient shorelines of 4,000 years ago. Different scenarios have been described in places that once had been covered by thick ice sheets or glaciers. When those heavy loads melted or moved across the land, then they potentially could create scouring or other effects. The details can vary depending on the amount of ice involved, its speed of movement or melting, and the physical properties of the underlying geological formations. In these settings, ancient archaeological remnants could be destroyed or displaced. Later, the altered terrain can create different prospects for how people could inhabit these areas. In some cases, when large amounts of ice melted, then the underlying landmass rebounded upward. Without the weight of the ice sheets bearing down onto the land, then some landforms could become raised upward. These kinds of circumstances have contributed to the rare preservation of some of the world's most ancient coastal sites. Even more factors have involved the ongoing processes of sedimentary erosion and deposition. The conditions are different in every location, but you should be able to recognize the patterns of erosion and deposition that have affected the shapes of landscapes through time. When you identify an archaeological layer, then you should be able to plot its original situation in the ancient landscape of its measured time period. You should be able to account for the position in its surrounding landforms, habitats, sea level, and larger context. Especially for coastal sites, their settings today tend to be remarkably different from their ancient contexts. In order to portray those ancient contexts accurately, you need to trace how the specific site locations have transformed through time. A large part of this effort requires coordinating the archaeological material with the chronology of changing climate and sea level. If you know the dating parameters of an archaeological layer, then you can begin to contextualize with reference to the known records of climate and sea level. those records can be understood at different scales of the global evidence, the details for each geographic region, and the localized variables of a particular site area. In any case, you should be able to reconcile the localized conditions with the larger regional or global scale of records of changing climate and sea level. Often in coastal areas, you can find the remnants of ancient tidal notches. Through time, the mean tide level will create a classic parabolic curve. These notches are made mostly by mechanical abrasion of waves, and they often are augmented by biological organisms causing further erosion. These tidal notches definitely refer to the positions of ancient sea level. You next can look for additional evidence to clarify when a notch was created and what else may have happened in the surrounding environment. In some cases, a tidal notch may have been created in an uplifted landform. If you can obtain a direct dating of old coral growth or limestone at a measured elevation, then you can conclude the rate of uplift of the landform. A limestone plateau originally existed as a coral colony. You can obtain a direct dating of when the coral last was alive, and you can coordinate this result with the elevation above sea level today. Other clues could come from remnants of an associated ancient habitat. In many coastal areas, you can identify the components of ancient coral reef ecosystems. You can compare the ancient reef formations with their modern-day counterparts, combining direct dating with measured elevations. Throughout the Pacific region, the records of tidal notches and ancient coral reefs have confirmed a region-wide higher sea level, sustained from approximately 3000 BC through 1000 BC. Enduring through this 2,000-year-long period, the sea level was between 1.5 meters and 2 meters higher than today. The precise timing and the magnitude naturally varied across the Pacific Basin, but the overall picture has been verified cross-regionally. With the cross-regional picture, you can clarify the localized site-specific details. At the Ritidian site in Guam, the ancient tidal notches and remnants of old coral reefs point to a higher sea level, about 1.8 meters higher than the modern level. Excavations verified more of these ancient coastal habitats, with direct dating of ancient corals and lagoon sediments in measured elevations, all cross-confirming the 1.8 meter higher sea level prior to 1100 BC and extending at least as early as 2200 BC. Furthermore, at the Ritidian site, the shellfish records showed a significant change, starting at the same time of the lowering sea level. Certain of the shellfish may have been over-harvested by people, but others probably could not have survived in healthy numbers through the impacts of the natural lowering of the sea level. The shellfish records at Ritidian were similar to the findings at many other sites of the region. Overall, Anodara clamshells declined rapidly after 1100 BC. Other shellfish taxa declined as well, for example as seen for limpets, sea urchins, and chitons. I then looked at the records for sites of different ages. For example, at the sites where nobody had lived until more recently, the Anodara clamshells never were found in much abundance, and therefore we can infer that Anodara clams did not survive in healthy numbers through the changing sea level in this area. Meanwhile, the later aged sites still showed appreciable numbers of limpets, sea urchins and chitons, at least at first, but then these shellfish consistently declined in the local records. In this case, the decline of limpets, sea urchins, and chitons was not associated with a change in sea level, but rather it occurred shortly after whenever people inhabited any site in this area, regardless of the time period. Continuing with the study at Ritidian, I considered how the changing sea level may have affected the positions of fresh water. In this particular area, fresh water is available not through any rivers or streams, but rather fresh water is contained inside the island's internal aquifer. Certain points of the aquifer could be accessed through deep caves, or through occasional seepage flows just above sea level. Now, with accurate information about the position of ancient sea level during specific time periods, we can understand better about where people could have accessed water above the ancient sea level at different times. Importantly, in studies of changing climate and sea level, archaeology provides material records that extend over long periods of time. In the example of the Ritidian site in Guam, we can learn what happened in the landscape through a number of changing periods of climate and sea level. One notable transition occurred a few centuries after people first were living in the region. The first settlers around 1500 BC had lived in specialized seashore niches, but then those exact niches no longer existed a few centuries later. Starting around 1100 BC, with the beginning of a drawdown of sea level, the coastal ecologies transformed substantially. People shifted the positions of their settlements. They gathered different kinds of shellfish in their basic diet, and they made other adjustments over the next several centuries of changing sea level and coastal ecosystems. Those cultural adjustments occurred at different paces and at different magnitudes over several centuries in total. Continuing forward in time, we can see a number of periods of when the sea level was lowering quickly or slowly. Those alternating periods can be coordinated with different cultural contexts of how people used their coastal habitats, along with ongoing use of their inland or upland zones. Later, around AD 1000, we can notice a major transition, not only at the Ritidian site, but also throughout all of the Pacific Islands region. By this time, the regional sea level had been stable, and the coral reef ecosystems were established much as we can see today. Meanwhile, climate globally was overall warmer and wetter, and seasonal weather patterns were largely predictable. In this context, populations grew in size and expanded into extensive territories all across the Pacific Islands region. Settlement structures became more formalized, and densities of populations began to increase. A few centuries later, around AD 1300, the growing populations met a problem. They no longer could rely on the same predictable and favorable climate of the prior centuries. Global temperatures were slightly cooler and drier, as well as unpredictable, with punctuated events of storminess and of drought. These unstable and overall less favorable conditions continued for some centuries. Meanwhile, we can see the termination of the previous trend of increasing population and formalization of land use patterns. In the places where people had developed maximum high-density land use patterns, they were forced to change their traditions. The outcomes were variable, including increased conflict and warfare. migration into other areas, adjustments in the sizes and organizations of communities, and overall transforming the management of landscape resources. As you have seen here, a long-term perspective in archaeology allows factual examination of chronological change in the natural and cultural environment. If our view into the archaeological record is too limited or missing pieces of the larger picture, then we cannot legitimately address issues of change through time. If you can be aware of how climate and sea level have changed, then you should be able to seek other forms of information in the same chronological sequence. You can consider how the water table was affected, with further implications about where people could live and how they could manage their basic food resources. This approach has produced informative, illustrative results in the Pacific Islands region, but the lessons could be applied anywhere worldwide. In a general research program, you can start with illustrating the shapes of ancient site layers and landforms in coordination with the climate and sea level of the dated time period in question. Next, you can populate those landscape models with evidence about site structures, inventories of artifacts, the range of shellfish and other foods, the composition of ancient forests, and any other lines of evidence that you can find. With a holistic view of an ancient site context, you can examine the relationship between the natural and cultural components of the environment. You can assess what aspects were created by natural conditions of the climate and sea level, and you can appreciate the cultural contributions within those contexts. Next, you can expand this holistic view of ancient site contexts. You should be able to consider two general perspectives. In a cross-regional perspective, you can look for consistencies or inconsistencies among sites of the same age range. In a chronological perspective, you can look for periods of sustained traditions versus periods of changing conditions. As I have outlined here, you can build a research program around the material facts. You can start with describing the real patterns and trends in the archaeological record, and then you can develop logical, hypothetical explanations that ideally can be tested and refined through relevant data. In concluding this episode, now you should be familiar with changing climate and sea level in a long-term archaeological perspective. Within this overall framework, you can consider the implications for any site-specific archaeological study, as well as more generally in understanding environmental relations. I hope that you enjoyed this episode and that you will explore more with the Archaeology Studio.